Hello guys, this is the second part of the lesson about polynomial long division, and the goal for today is to show you some additional long division problems so you can practice a little bit more. So I'm going to show you an introduction of a different strategy which is called the synthetic division, which is much faster. The problem is that there are lots of applications in which it's not going to work, so there are some special conditions that needs to be true in order for the synthetic division to work. But I will just introduce today, and then in the next lesson you can practice also on synthetic division. Okay, here is a first example. We want to divide 2x cubed plus 4x squared minus 5. And we want to divide this by x plus 3. So as I asked you in the previous lecture, make sure you work these problems by yourself first, and then you check with me. Okay, so what we do is we write the dividend on the right hand side. So we have 2x cubed plus 4x squared. And notice that in this case, if you look at the dividend, which is all of this, between x squared and 5, there is a negative 5, there is a missing term here. The x is missing. So what's convenient to do is to replace the x with the 0x. So you're going to write 4x squared, and then you're going to put a 0x, okay? And then you're going to write the minus 5, okay? So this is just convenient. And then the divisor, we have x plus 3, so we're going to keep it, x plus 3. Okay, so how are we going to divide this? So what we do is we compare the highest degree term of the dividend with the highest degree term of the divisor. So we divide 2x cubed by x. Or you can ask yourself, x times what is going to give you 2x cubed? And this term is going to be 2x squared. Then we pick up 2x squared, we first multiply by x, so practically, I can even put arrows here, you use a distributive property, so 2x squared times x is going to give you 2x cubed, and then 2x squared times 3 is going to give you 6x squared, and both are going to be positive, but then we're going to change the sign, so we can combine the terms. So this becomes negative, and now we can combine. So this simplify. The first term is always supposed to simplify. If it doesn't, double check your calculation because there must be a mistake. And then 4x squared minus 6x squared is negative 2x squared. We take down the next term, which is 0x. And then you will compare again negative 2x squared by x, which divided give me negative 2x. Now we multiply this negative 2x by x and negative 2x by 3. So what we have is negative 2x times x is going to be negative 2x squared, and negative 2x times 3 is going to give you negative 6x. We change the sign, so this will become positive, this will become positive, and then we combine the terms, so the first is supposed to simplify, and now we have a 0x plus 6x, which is going to add up to 6x. At this point you should see why is it convenient to insert this 0x that was not here. If I kept instead the negative 5, this could become confusing because you were trying to combine the negative 5 with the positive 6x, and this may lead to some mistakes. So to avoid this mistake, just put a 0 whenever a term is missing. So 0x plus 6x add up to 6x, and we can still divide, so we bring down the negative 5, so 6x compared to x, so if we divide we get a 6, and then 6 times x again is a 6x, and 6 times 3 is 18, so plus 18. We change the sign, so this is negative, and this positive now becomes a negative, and we combine the terms. First term is supposed to simplify, and then negative 5 minus 18 is negative 23, and this is going to be your remainder because it cannot be divided further by x plus 3, so that's a remainder. So how are we going to write the final answer? Well, this is equal to whatever we got here at the top, which is a 2x squared minus 2x plus 6, and then we have a remainder of 23, so we can write minus 23 divided by the divisor, which is x plus 3. Notice how we got a second degree term as a result, because we are dividing a third degree polynomial expression by a first degree polynomial expression. Since we subtract exponents when we divide, we end up with a second degree polynomial expression. Also, I remind you that if you want to check that your result is correct, you are going to multiply the quotient by the divisor, so 2x squared minus 2x plus 6 by x plus 3, and then make sure you add up the remainder, which is negative 23, to get the dividend. Okay, so you can always check by yourself that the answer is correct. Okay, let me show you an additional example. And this example probably a little bit more interesting because it's based on the formula of the difference of cube. So x cubed minus 1, and we want to divide this by x minus 1. Well, if you are familiar with the difference of cube formula, you can immediately write the answer in this case. What I can say right now is that we are supposed to get a remainder of 0. Okay? And we can verify this, so I'm going to show you the long division. And then I'm going to take advantage of this example to show you the synthetic division process. And then again, in the next lesson, you will become more familiar with this process, which is much faster than long division. But again, it will not work all the times. While long division will always work. Okay, so what we need to do? Let's write the dividend, which is x cubed minus 1. Notice how there are missing terms. X squared is missing, so I'm going to write 0x squared. X is missing, so we're going to write 0x, and then we're going to keep the negative 1. On the left hand side, we write the divisor, which is x minus 1. And as always, we are going to compare the two highest degree terms of the dividend and divisor. And x cubed divided by x is x squared, so we're going to write this x squared here at the top, and then we multiply. X squared times x is x cubed, and x squared times negative 1 is negative x squared. So we change the sign, so this becomes negative, and this becomes now a positive x squared, and now we can combine, so the first term will simplify. So now we have a 0x squared plus x squared, which combine to 1x squared. We take down the next term, which is 0x. Again, if I didn't put this 0x squared as 0x, it will not be incorrect, but it will probably become confusing because instead of 0x squared, I'm going to have this negative 1. And then you have negative 1 plus x squared, and again, this may lead to mistakes. You should just keep the x squared, okay? So if you are okay with that, you can avoid putting this 0, but based on my experience and based on the type of mistakes I see from students, it's much better to write 0x squared and 0x, okay? Alright, so now we're going to compare this x squared with x, so we divide, we get x, so we're going to write plus x. X times x again is x squared, and x times negative 1 is negative x. We change the sign. So this becomes negative and this becomes positive. We combine the terms. This will simplify, and now 0x plus x is going to give me positive 1x. Okay, and then we're going to bring down this negative 1, and from our last time, we're going to compare x by x, which is going to give me 1. If we use distributive property, 1 times x is x, 1 times negative 1 is negative 1. And you can see if you subtract these two quantities, you get 0. If you don't, change the sign, and then combine the terms. Well, but this and this simplify, this and this simplify, so we end up with a remainder of 0 in this case. Okay? So our answer is just this expression, polynomial expression degree 2, which is x squared plus x plus 1. And if we multiply this by x minus 1, we should get x cubed minus 1. So we get a remainder of 0, so this is your final answer. Okay? Okay. So now I was saying that we can solve this with a different process, which is called, so I just introduce in this case, is called the synthetic division. Okay? And what you do with synthetic division, you don't write any x, you don't write any variable, you only work with the numbers, okay? So this is what you do. Okay, the dividend is x cubed minus 1, and the divisor is x minus 1. So you write only the coefficient of the dividend first, that are 1x cubed, so there is a 1 in front of x cubed. The x squared term is missing, so you just put a 0. The x is missing, so you put a 0, and then the negative 1 is going to stay. Okay? So practically this represents the x cubed column, this represents the x squared column, this represents the x column, and this represents the constant term, so the number column. Alright, so then what you do, you draw these two bars. Okay, just 1 second. So you draw the two bars, and here on the left hand side you are going to write the opposite of this number, which is negative 1. So let me show you what the number I'm talking about. So take a look at the divisor. The divisor is x minus 1. So I'm going to write the opposite of this number. Okay, so here let me write down opposite. So the opposite of negative 1 is positive 1. If I had an x plus 1, I would have written instead negative 1. So we're going to write the opposite of this, which is 1. Okay? So this is what we do. And this is how the algorithm is going to work. You bring down the first number, which is 1, and then I multiply this 1 by this 1 here on the left side. 1 times 1 is 1, so I'm going to write this here. Then I'm going to adapt 0 with 1, 0 with 1, 0 plus 1 is 1. I'm going to multiply again by this 1, 1 times 1 is 1. And then I'm going to adapt again 0 plus 1, which is 1. I'm going to multiply again 1 times 1, which is 1, and negative 1 plus 1, which is 0. We're practically done. Okay? This last row represents your solution. You just need to be able to interpret the meaning of this solution. Okay, the first number you see here is 0, is always the remainder. This represents the constant term, which is the number by itself, constant term. This is always the x, and this is the x squared. So these are the coefficient of x squared, x, and the constant term. So what we get is x squared plus x plus 1, and we are done. Okay? So this process is much faster, as you can see. Okay, it's the first time you see it, so you may be a little bit confused on how it works, and it makes sense. So in the next lesson, I will show you many other examples on synthetic division, and you will see that it's actually a very simple process. Okay, but for right now, I can tell you that we can solve this type of problems. We can divide using synthetic division. Now, in general, synthetic division, and this is very important. So let me write it down. Synthetic division works only, okay, let me erase this. So only if the divisor has the form of an x minus c or x plus c, where c is a real number. Okay, x minus something, x plus something, okay? Then, like in this case, we have x minus 1, so great, it works. If we had an x minus 10, or an x plus 10, an x minus 5, an x plus 5, it will work. But if we have an x squared, an x cubed in the divisor, this is not going to work, okay? So that's why we need to learn polynomial long division because it will always work. Synthetic division is nice, it's fast, but it works only in this condition. Okay, so next lecture we're gonna talk about synthetic division. As always, let me know if you have any questions. Thank you and have a good day.